there, enjoyed those sounds? Well, then let's talk about sound today. Imagine sound as a dynamic traveler embarking on a journey through various terrains like air, water, or even solid structures. What is sound? Let's dive into the fascinating world of sound with our interactive demonstration, one by one in a captivating and easily understandable way. By the end, you'll have a richer appreciation for the science of sound, delving into elements like pitch, loudness, and timbre or quality. But have you ever wondered, how does sound travel? It's simple. It all starts with a mechanical movement, like pouring hot milk in a mug, clapping your hands, and shouting in a louder voice. Strike the temple bell to make it ring. Touch the bell when it rings. You will feel vibrations and so on. So, when you hit the bell, there's a movement, which causes some vibration in the molecule. As it traverses its path, it creates compressions, and rarefactions follow one another, causing the particles to travel through the medium in its surroundings to pass along its vibrant energy. It's a fascinating chain reaction, moving from one particle to the next until it finally reaches our ears. Get ready to uncover the magic behind every note and noise. It's discovered that faster something vibrates, the higher the pitch, and vice versa. We can verify this with our own voice. Place your fingers on your throat and speak. You will feel the vibrations. When vocal cords are vibrating slower, lower is the sound pitch. How will changing the amount of water in a glass affect the sounds it makes? Here we have 4 glasses of identical shape and size. When tapped with spoon, each glass produces a similar sound. Let's make it vibrate more quickly. We are going to fill the 4 glasses with different amounts of water. Here we are using color water to visualize properly. Strike them with spoon and listen to the difference in pitch to feel that science at work. Where the water level is high, see what happens. You can hear the pitch go up where the water level is high, lower the sound. Why does the pitch change? When we tap the bottles, the glass and the water vibrate. Having to move all that water slows down the vibrations of the glass, and thus in turn slows down the frequency of the sound waves. This produces a lower pitch. Now, let's dive into some cool physics with a tuning fork. What is a tuning fork? A tuning fork is a small 2-pronged metal device that produces a specific pitch when struck. It's commonly used to tune musical instrument as it vibrates at a precise frequency, providing a standard reference tone. Now, we are going to add some sprinkle. Start by taking a small bowl of water. Strike the tuning fork hard on a rubber pad and then dip it into the water. See what's going on. Watch as the water shoots all over the place. This happens because the vibrating tuning fork transfers energy to the water molecules, causing them to splash. Doing it one more time, we can't see the forks moving, but when I put it into the water, we can clearly see the energy and the speed at which those forks are moving when it has that sound. Let's move to the next one. Cover the top of a glass jar with a tightly stretched rubber sheet. Sprinkle some salt on the sheet. Now vibrate the tuning fork and place it close to the sheet. Observe the salt particles dance. This magic occurs because the sound waves from the vibrating tuning fork transfer energy to the particles of the rubber sheet, making it vibrate, which then make the salt particles move. These experiments demonstrate the energy transfer from the vibrating tuning fork to other materials, visualizing the invisible world of sound waves. Isn't it fascinating to see physics come to life? We know louder sound are produced by sound waves of higher amplitude. Let's visualize this concept with a simple experiment. We need a metal glass and a tuning fork. Pour some water in a metal glass. Now we will test the amplitude of the sound waves. Place a suspended plastic cap with a thread against the glass filled with water. Now strike the glass with a vibrating tuning fork and observe the sound. First softly, then a little harder, and again very hard. The suspended cap will move when the glass is struck harder. This indicates that the glass vibrates with a higher amplitude when struck harder. So we can conclude the difference in loudness of sound is due to difference in amplitude of wave it produces. The next characteristics of sound is quality. By the quality of sound we mean whether it is rich or flat. Even if a harmonium or a piano or a ukulele produce sounds of the same frequency, pitch and amplitude, that is loudness, you will be able to tell them apart because of the quality of the sounds will be different. Actually, when a body vibrates, it never produces just one frequency. When you play a particular note on a piano, for example, it produces sounds of frequencies which are multiples F, 2F, 3F, and so on, of basic loudest sound called fundamental frequency F. The other sounds mixed with it are softer than the fundamental and of varying loudness called harmonics. When the same note is played on a different instruments, the basic fundamental frequency generated is the same. However, the harmonics present and their relative loudness are different. This is what determines the quality of sound. Generally, a sound is richer if a greater number of harmonics are present. I hope you had as much fun with these budget-friendly demonstrations as I had. They're a fantastic way to explore science right at home. Be sure to give them a try and share the experiment with others. Until next time, take care and keep experimenting.